Hello and welcome to Add-on. So today in this video, we are going to discuss about the working of cyclotron and then derive the cyclotron frequency and the kinetic energy, maximum kinetic energy of an ion accelerated through it. So have you ever wondered how scientists manage to accelerate tiny particles like protons to incredibly high speeds? Or why would they want to do that in the first place? One of the answers is that the cyclotron, a powerful tool that accelerates particles and makes groundbreaking research possible. So, let's begin with the basic principle. Imagine you have positively charged particles like protons or deuterons, a type of hydrogen ion. A cyclotron uses magnetic and electric fields to boost these particles to very high energy. Why? By giving these particles high speeds, we can use them to study atomic structures or cause nuclear reactions by smashing them into atoms. Now let's get into how this machine actually works in the real time. So picture a cyclotron as a flat circular machine. Inside, we have two large hollow semicircular metallic containers shaped like the letter D. Okay, these are called Ds because of their shape. They are connected to a high frequency alternating voltage which switches their electric polarity back and forth. But here is something interesting. What do you think happens when a charged particle enters one of these Ds? Well, one, once the particle enters the D, it does not experience any electric force. That might seem strange, but it's because the electric field inside the conductor is zero. Yes, zero. So the particle just moves along the D without being affected by any force. Now here is where the cyclotron gets clever. A strong magnetic field is applied perpendicular to the D. The magnetic field causes the particle to follow this circular path within the D. The magnetic force keeps it moving in a circular rather than letting it circular path rather than letting it fly off in a straight line. This is due to the relationship between the magnetic field and particle's velocity, which can be described by the equation R equals to mv by qv. So here we can see that the electric field within a conductor is zero. Therefore, when an ion with mass m and charge q plus q enters the D, it encounters no electric force. On the other hand, ion describes a circular orbit with radius r and constant speed v when subjected to the action of the magnetic field. And it is mathematically expressed as r equals to mv by qv, where r is the radius of the particle, m is the mass of the particle, v is its velocity, and q is the charge of the particle, and b is the magnetic field strength. So the faster the particle moves, the larger the radius of the circular path. Now here is the next piece of puzzle. How does the cyclotron keep the particle accelerating? The key lies in timing. The particle completes half of the circular path inside one D. Let's show it in the figure. And then crosses it into another D. But just as it's about to cross over, the voltage applied to the D switches. As it is an alternating voltage, so reversing their electric charge, this change in polarity creates an electric field between the two lanes here, which gives the particle a push or a kick of acceleration. So after gaining this boost, the particle starts moving in another D, where it follows a slightly larger path due to its increased speed. And when it returns to the gap, the voltage switches again, giving it another kick. This process repeats, and with each path, the particle gains more and more speed. And we can calculate the angular velocity of circular motion as omega equals to v by r equals to qv by m. And the time it takes for the particle to complete a half circle within the D is given by t equals to pi by omega equals to pi m by bq. The timing is crucial because the particle will only get accelerated if the voltage changes just as the particle crosses the gap. The frequency of the voltage source, which oscillates back and forth, is called cyclotron frequency, and we can derive it as F equals to dq by 2 pi m. So as long as we keep the frequency in sync, the particle will continue to accelerate. Eventually, the particle's path spirals outwards, forming larger and larger circles as its speed increases. It keeps doing this until it reaches the maximum radius, which is called R max. So let radius of the outermost orbit described by the ion is R max. Maximum velocity achieved by the ion in its final orbit is V max. The equation of motion of ion in magnetic field is expressed as dq max equals to mv square max by R max. So now let's calculate the maximum energy that the particle can have when it's ready to exit. The maximum energy is given by E equals to half mv square max. So using this relation from the motion of equation of a magnetic field, where we can substitute to express the energy in terms of magnetic field B, the radius R, and the charge Q, and the mass of the particle M, we have E equals to B square R square max by 2 into Q square by M. So this formula tells us that the particle energy depends on the strength of the magnetic field, which is B, the maximum radius R it reaches, and the particle's own charge Q and the mass M. So as half of its ion's journey time along the semicircular path equals oscillation of the high frequency voltage of light, we have Qm by Bq equals to T by 2, or T equals to 2 pi m by Bq. So to summarize, in a cyclotron, we have a charged particle like a proton accelerates by moving in a spiral path, gaining speed each time it crosses the gap between the D's. This one. The magnetic field keeps it moving in circles, and changing electric field between the D's boosts its speed. Eventually, it reaches high enough energy and exceeds the cyclotron at maximum kinetic energy. Like this. This entire process is based on the principle that the frequency of the particle's circular motion matches the frequency of the voltage applied across the D. It is connected to an alternating voltage, which is very high. So cyclotrons are widely used in nuclear physics and medical treatments, such as creating radioactive isotopes for cancer therapy. They show just how powerful and precise scientific tools can be when we understand and control fundamental forces like electric and magnetic field. And that's the working principle of cyclotron. Hope you understood the mechanism. Thanks for joining me.